Okay, now we are going to discuss about this experiment. This experiment name is going to call as the notch calibration setup. First, we are going to discuss what is meant by the notches. Notches means these are the instruments to measure the flow rates, especially in the open channels or the canals. Okay, notches, there are the different types of notches are there. V notch, rectangular notches, trapezoidal notches are there. Especially the notches can be defined as a sharp edge obstruction over which flow of liquid will be happens, over which the flow of liquid will be occurs. I already mentioned the notches means those are the instruments to measure the flow rate in the canals or the open channels. The venturi meter, orifice meters as well as nasal meter, those are also the flow measuring devices, but those are the flow measuring devices in the closed conduct. In a closed pipes, those are the instruments we are going to use to measure the flow rate, but the notches as well as the wires, those are the instruments to use to measure the flow rate in the open channels and the canals. Here I can show that one how the V notch will be looks. This is the notch. I already mentioned the notches means a sharp edge construction. A sharp edge construction. Here you can see that the shape is the V. This one is going to call as the V notch. V notch in construction. And V notch, the different types of V notch will be there. 60-degree angle V notch, 90-degree angle V notch. This you can see that this is the 90-degree V notch. The angle between this to this side is what the 90 degrees there. This is going to call as the 90-degree V notch. In the same way, we have other V notches also. That is what 60-degree V notch. Here you can see that the angle between these two edges is what 60. You can see the edges are very sharp to reduce the friction between the fluid as well as the surface. So the V notch are the sharp edge in constructions, means the notches are in the sharp edge construction. I shown the V notch. In the same way different notches are there. That is what trapezoidal notch. Based on the shape, we are going to call this is a trapezoidal notch, and based on the shape of this one, we are going to call as the rectangular notch. But in our syllabus, we have only the V notch for a degree of 90-degree V notch. So this point we are going to call as the crust level. This point, this is the crust level. In the same way, suppose if you are using the trapezoidal level, this bottom side, this bottom one, we are going to call as the crust level. And what is the fluid? The jet of the water of fluid is coming from this notch. We are going to call as the nape. What is the fluid that is coming out from this notches? We are going to call as the nape. Whatever may be the shape, whether a trapezoidal notch, what the water is coming from this notch, that one you are going to call as the nape. Come to this experiment. The main parts is this is what we are going to call as the channels, open channels. This is not the closed pipe. This is the canal-like structure. In this type of structures, we are going to use the notches as well as another experiment what we are going to call as the wire. We are going to measure the flow, especially in the open canals. And also we can see this one. This one you are going to call as the baffle plate. This is the simply used for to get the fluids to be straightened, to avoid the disturbance in the fluid when it is coming from the pump. To avoid that disturbance, to make the fluid straight, to move the fluid to flow straight, this baffle plate is used. And later, here the scale is there. This one you are going to call as the surface gauge level. First, we have to set for the crust level. Here the point, the needle is there. The needle should be touched to that crust level. That becomes our reference. After how much of the water rises, that time this needle will be raised and the corresponding reading should be taken out. So the part of the experiment I already explained. This is the canal and that side is the notch, and the important what the scale is required to measure that height. Now we are going to conduct. I will going to show the how to conduct the experiment. As usual, first we should on the main. Later we should on the pump. Using the control valve for the different flow rate, we have to conduct the experiment. Now First, we have to fill the water up to this crest level. We have to fill the water up to the crest level. Now the water level is somewhere here is there, somewhere here is there. For any experiment, if you are conducting the notches, first carefully fill the water up to the crest level. Then using the scale, make that point is the reference point. Now I will show that experiment how to conduct that one. Now we are going to start the experiment. The mains is on. I am going to on the pump with different. First, I am going to set the water at the crest level. Now the water is filled above the crest level. Now the water is filled above the crest level, but I have to wait for the water to be spilled out and come to the crest level. Just 2 or 3 minutes we have to wait. Whatever the excess water is there above the crest level, let them to come outside. When the water level comes to the crest level, we will take it in. Now the water is come at the crest level. So once the water comes to the crest level, we have to set that is the reference point. Here we can see that one. This is the scale. Here the needle is there. Here is the needle is there. Here is the water level. Here you can see here is the water level. I have to make this pointer to touch that water level. Carefully, just the needle should be touched to that water level, and fix this knob also. After the next reading, don't touch this knob, only change this one. Here you can see this one is the reference to that 0. This line is reference to this one, that is the 0 reference, 0 point, and that is the reference point. Now next I am going to on the pump once again. I will give the discharge to the fluid. Now the water level somewhat it will be increases to this one. And what will be this rise of water I have to taken from this scale. I am going to on the pump. What the water is coming, this one is going to follow the the water is coming, this one is going to follow the Here you can see the rapid straightening the fluid. Now you can see the water is rising up to this much. Now the water is rising up to this much. Now I have to take this needle outside. Now how much water is rising? This edge should be taken. This rise of level, the water level should be taken from the calibration. And this is the one trial. Next, the same thing. Next, the same thing for the 10 centimeter height. For the 10 centimeter height, how much time is taken should be found out using the stopwatch. For example, 36 to 42 centimeter. For 10 centimeter height, how much of the water is collected, that will be noted from the stopwatch. So The procedure is the same thing. For the known height of water level rise, how much of the time is taken, that should be taken from the stopwatch. In our experiments, for all the experiments, we will consider for 10 centimeter height, how much of the time is taken. That one is being taken by the stopwatch. I already mentioned this one is going to call as the collecting tank, and also you are going to call as the measuring tank, because the measuring scale is attached to this tank, that's why you are going to call as the measuring tank. Now, once again the experiment is repeated for the higher discharge. Just you change the other discharge according to what the rise of water will becomes using the needle. That needle should be touched to that water level. Then what is the rise, that should be noted for the calculation. Here also the two readings is required. One is the scale reading. This is the surface gauge level. This is the how much of the water raised. That should be required for one calculation, and how much of the time is consumed for the 10 centimeter height of the water. One is the time, one is the h. Totally two readings is required for calculate the drip calculation.
Okay, the demonstration of calibration of VNACH is over. How to conduct the experiment, the steps, all those things we explained. Now we will going to discuss about how to do the calculation part of the VNACH. There we did discuss the different shapes of the natures, rectangular natures, square natures, V natures, all those things we discuss. In our lab for our syllabus, we having a VNACH at 90 degree centigrade. The angle between the two edges, the angle between these two edges is 90 degree. Now come to the calculation part. Before going to the calculation part, what the observation is the area of the collecting tank as well as what angle of the notch. This is the thing should be noted from the experimental setup itself. The specification panel is attached to the each and every experiment. You just before doing the calculation, you just note on the values from in the specification panel. There is no need to buy at the specification of the experiments. For all the experiment, the specifications is available on the particular experiment itself only. Next, come to the tabulation, tabular column. This here we have to take the two readings. The initial crust level, that is the reference point, that is the 0 for all the different cases. Final crust level should be taken, depend upon the different flow rate, and this difference will be gives head over the notch. And this is the theoretical discharge. Discharge should be calculated, and time taken for h is equals to 10 centimeter rise of water in 3 seconds. This is the reading should be taken from the measuring tank. Okay, we know this procedure is same for all the experiment, that is for the major lasers, minor lasers, as well as flow through the devices. All three experiment, including this, also the same procedure. For a known amount of rise in the collecting tank, how much time is taken, that should be calculated. That should be noted down. Okay, the same thing I will going to show the photos of that one once again. Snapshot of that readings where you have to take. First, I'm going to tell the initial crest as well as the final crest point. Later, this one. Here also, the only the two reading is enough to calculate the unknown things. Okay, this is what the observation for the Venus that is available on the panel itself. The area of the collecting tank is 0.17 meters square. Once you note on that one, you can easily do the calculation part. Here we can see the crust level is the always what the initial crust level is always the 0. Then depend upon the discharge, how much the water level is raised here. 1 minute. How much the water level raised here, you place that needle up to that point. From 0 to here, how much the height is taken, that should be noted on. This is the one reading, crust level, initial as well as the final crust level. For the another discharge, if it is high discharge, the point will becomes here. Once again, you place the needle here. Automatically, the square will be goes up. The next is what? This one, from 0 to this one. This is the edge. Next, next, same thing for 10 centimeter height, the rise of water in the scale. How much time taken is should be taken from the stopwatch? Only the two readings should be taken for the calculation part. So we taken the what initial reading as well as the final reading. The difference is what head over the notch and how much water rise for a 10 centimeter that the time taken is taken in the by the stopwatch in t seconds. So using this one, we can do the calculation. Very simple calculation. Actual discharge can be calculated by this equation, area into h by time taken. Area into this is the area of the collecting tank. H is the 10 centimeter height of water rise in the measuring tank. T is the time taken for the rise of water of a 10 centimeter. This will give the Q actual. Then Q theoretical, this is the equation 8 by 15 square root of 2g. The square root is only for this quantity, not for the remaining quantity. The square root of 2g, square root is only for 2 into acceleration due to gravity, not for the next part. This is next part. Into tan theta by 2. Theta means that is the angle of the notch. Here is the 90 degree. So tan 90 by 2, 90 by 2 is 45, tan 45 is the 1. Next, H. H is the head over the notch that is obtained from the initial crust level as well the final crust level. That should be taken in the meter. That value should be substituted here. Then you will get the Q theoretical value. Then coefficient of discharge means the ratio of Q actual by Q theoretical, you'll get the coefficient of discharge. So this is the experimental part, calculation part of the calibration of V notch. What are the results you got it? Just you write that one. And just this is the experimental sketch. Thank you for watching this video.